In this lecture, we will be discussing about the construction and working of solar cells. So we have studied about the solar thermal electric systems in the previous lecture. Another method for generating electrical energy from solar energy is the solar photovoltaic systems. And a solar cell is the fundamental unit of solar photovoltaic systems. So what is a solar photovoltaic system? So they are the systems that generates electrical energy directly from solar energy using photovoltaic effect. So now what is photovoltaic effect? Photovoltaic effect is a phenomena by which voltage or electrical current is generated in a photovoltaic cell when it is exposed to sunlight. So when a photovoltaic cell is exposed to sunlight, when solar radiation falls on it, it will generate electrical current and voltage. This phenomena is known as photovoltaic effect, and the systems that uses this phenomena for generating electrical energy are known as photovoltaic systems. So we have already said that a solar cell is the fundamental unit of a photovoltaic system, and now let us see how a photovoltaic cell or a solar cell is constructed and how it generates electrical energy. Solar cells are made up of semiconductors. So we know there are different types of semiconductor. There are pure semiconductors, that is intrinsic. Then impure semiconductors having impurities, they are extrinsic semiconductors. They can be either p-type or n-type semiconductors. And if we consider n-type semiconductor, there are free electrons present in n-type semiconductors. So these free electrons, even if these electrons are free, they are present in the valence band, in the outermost shell of the atoms, and they are the valence electrons. So if these electrons has to become conducting, if they have to conduct, what? We have to supply energy. These electrons has to excite from their valence band to the conduction band. So valence n-type semiconductor free electrons ഉണ്ട്, പക്ഷേ അത് conducting electrons അല്ല. In order for it to be conducting, it has to be excited from the valence band to the conduction band. So in solar cells, there are semiconductors. They are made up of semiconductors and they generate electricity. There will be free electrons, free charge carriers when they absorb light. So they are usually made up of silicon, and the silicon solar cells consist of a single crystal of silicon diffused with doping materials to form p-type and n-type semiconductors. So we know solar cell or a photovoltaic cell is basically a p-n junction diode. So we need a p-type semiconductor and an n-type semiconductor, and we have to make a p-n junction using these two semiconductors. So what we are doing is, a single crystal of silicon is taken and this silicon is converted to a p-type semiconductor and n-type semiconductor by doping this with suitable doping materials, suitable doping elements. So this single crystal of silicon is converted to a p-n junction diode. So we will take a single crystal of silicon and one side of that silicon is doped with a pentavalent impurity like arsenic or phosphorus. So we know silicon is having 4 electrons in its outermost shell, and when we add a pentavalent impurity, that is an impurity having 5 electrons in its outermost shell. So when this pentavalent impurity is added to the silicon crystal, the 4 outermost electrons of the pentavalent impurity forms covalent bonds with the 4 outermost electrons of silicon, and one of the electrons become a free electron. Okay. So thus an n-type semiconductor is formed on that side. So that side on which a pentavalent impurity is added, there an n-type semiconductor is formed, and on the other side of this silicon crystal, a trivalent impurity is added. The other side of this silicon crystal is doped with a trivalent impurity, like boron. Okay, when this trivalent impurity is added, that impurity will have 3 electrons in its valence shell. So these 3 electrons will form covalent bonds with 3 electrons of the silicon, 3 valence electrons of silicon. So there is a deficiency of 1 electron. Silicon is having 4 outermost electrons. So in order to form covalent bonds, one of the electron needs another electron from this impurity. But impurity can provide only 3 electrons. So there is a deficiency of an electron known as hole. So there will be additional holes, and such a semiconductor is known as a p-type semiconductor. So the same single crystal of silicon is converted to a p-type semiconductor and an n-type semiconductor, and between the p layer and an n layer a depletion layer will be formed. Okay. And when photons are received, when the solar cell is exposed to sunlight, they will receive photon. So photons are packets of energy. So when photons falls on this PN junction diode, what will happen? So there are free electrons in the n side. So these free electrons in the n side, on absorbing solar radiation, excite from valence band to conduction band. So they becomes conducting electrons. They will move from n side towards the p side, and similarly holes from the p side will move towards the n side. So there is a movement of charges, and if we provide contacts, metallic contacts on the n side and p side, we can make this electron flow, this flow of charge carriers through an external load. So എന്നിൽ നിന്ന് പിയിലേക്കും പിയിൽ നിന്ന് എന്നിലേക്കും charge carriers in the flow ഉണ്ട്. If we are considering electrons are flowing from n region to the p region. So if we provide a metallic contact here and we connect that contact to a load through conductors, what will happen? The electrons from the n region will flow through this conductor, through this load, then to the p region. So by providing metallic contacts, we can collect these electron flow to an external load. Thus we will get electrical energy in the output. So this is the basic working of a solar cell, a PN junction diode. So current will continue to flow as long as electron hole pairs are generated by receiving solar radiation. So as more and more solar radiation is there, it breaks the bond between electron hole pairs. It creates electrons and holes. More electrons and holes will it will break that covalent bonds. The solar radiation, energy from the radiation helps to break the covalent bonds. So electrons will get free from the covalent bonds. So when electrons moves away from the bond, there will be a deficiency of electron, that is hole is formed. So as more and more solar radiation is being incident on the solar cell, more electron hole pairs are generated, thus conduction increases, output from the solar cell increases. And the voltage, output voltage that a single crystal, a single junction silicon solar cell can give is about 0.5 to 0.6 voltage. Maximum output voltage that a single junction silicon solar cell can provide is about 0.5 to 0.6 volts. So this is all about the construction and working of solar cells.